Hi guys, so let's solve this question. It says for complex number z is equal to cos theta plus I sine theta, which is like it's given in a polar form. This is a polar form. Prove that z to the power of n plus 1 over zn is equals to 2 cos n theta. All right, so there's something to prove. We know what the answer we want. So if we simplify what we need to prove, what I might do is I might write it as z to the power of n plus, this can be written as z to the power of minus n is equals to 2 cos n theta. All right, so now here we know that if they have given z and z, the complex number is equals to cos theta plus I sine theta, z to the power of n is going to be the whole to the power of n for this, right? And according to de Moivre's theorem, we know that z to the power n in this case is going to become cos n theta plus I sine n theta. Why is this? Because we don't have r in front of it. So r, that means is 1. 1 to the power of n is going to be 1. All right, so that won't affect anything. And similarly, z to the power of minus n is going to be cos minus n theta plus I sine minus n theta. All right, so these are both because of according to de Moivre's theorem. Right, I hope that's making sense so far. Now we are going to work on the left hand side of the equation they have given us. So left hand side is z to the power of n plus z to the power of minus n, right? So now what we have to do is we have to substitute the values we have. So we have cos n theta plus I sine n theta, let's put that in brackets, plus z to the power minus n, we have this whole statement there, so cos minus n theta plus I sine minus n theta. Now if you remember in trigonometry, you must have done odd and even functions. All right, so there are odd functions where when the function has a negative part of it, the answer is minus f of x. All right, and we have even function that when function is negative of x, then it becomes fx. All right, so if these are the cases, it's called odd and even functions. Now with cos, we know that cos is an even function. All right, so when cos is even function, that means cos of minus n theta is going to give us cos n theta, right? Whereas sine is an odd function. So when sine is an odd function, it's going to give us sine minus n theta will give us minus sine n theta. All right, if you don't know odd and even functions, you might have to go back. I don't think I have created a video on that. I might create next week sometime when I have some time, or you can just Google. Someone must have already made a video on odd and even functions. All right, if you do not know, it's really, really important for you to understand odd and even functions for this question. And I'm sure this is an excellence question. So now let's go ahead and substitute those values in. So that is going to give us cos and theta. The first two are normal, positive function, so that doesn't change at all. For the other one, now let's just put this away a little bit so we don't have to move our stuff. I'll just move it down. And I am writing the next one. So in the next one, cos n theta is cos n theta is just cos n theta. So that is going to be plus cos n theta, whereas sine theta is now sine minus n theta is now minus sine n theta. So it's going to become minus I sine n theta. So here we have I sine theta, or I sine n theta, and here we have minus I sine 1 theta, which will cancel, make it 0. So we are left with cos n theta plus cos n theta, right? And that now gives us 2 cos n theta, right? Now let's see what they are asking. They are asking us to find 2 cos n theta, right? So we are on the right path. So now this is equals to right hand side. Left hand side is equals to right hand side, hence proved. Right? Hope this makes sense.